A very good morning to all of you. Again we are here to discuss a very important phenomena related to sequential circuit, that is JK flip-flop. Now in previous lecture we have discussed SR latch and SR flip-flop. Now this JK flip-flop is somewhat similar to SR flip-flop only, but with 10% of change, right? We can say that 90% of SR is known to be a JK flip-flop. Now what is this 10%? 10% means 5% of the toggling phenomena and 5% of this circuit diagram. So we are having some sort of change in a circuit diagram, and we are having some sort of change in a truth table, right? So we are going to see how JK and SR are different from each other. Okay, so we'll be discussing the circuit diagram. K, this is J, and this is a clock pulse. This is a NOR gate, universal gate. This is Q, this is Q bar. Okay, now as far as the SR flip-flop is concerned, it is as same as that as this JK flip-flop. Now, so what is the 5% of change? The 5% of change is that we will be giving a feedback from output to the input. Here also output to the input, and rest the circuit will remains the same. Okay, so this is a JK flip-flop. Now we will be dealing with a characteristic table. Characteristic table. I have told you earlier that in characteristic table we will be having a present state, that is Qn, the inputs, the JK, and the next state. Okay. Now we are having three inputs, Qn, present state, J and K. So the combination will be 8, 2 to the power 3. Okay. Now we have to deal with the characteristic table. The basic phenomena behind the JK flip-flop is that for 0-0 condition, whatever be the previous state, the next state will going to be the same value. For example, for 0-0 condition, if the present state is 0, the next state will be 0. 0-1 means reset condition 0, 1-0 means set condition, it is 1. Now 1-1 condition in SR flip-flop, the 1-1 condition will be having a don't care, or you can say undefined state, but in this for 1-1 condition we will be having the inverted form of Qn. It means if 1-1 condition is there, Qn is 0, the output will be 1. We will be having the inverted form of this Qn. For 0-0 condition, again there will be no change, whatever be the present state, there will be the next state will going to be the same value, that is 1. 0-1 condition, again 0, 1-0 condition 1, and again for 1-1 condition we will be having the inverted form of the present state, that is 0. Here it is 1, the output will be 0. So this is the another 5% change. This and this. These two situations are known to be toggling phenomena. Okay, so the circuit diagram 5% and the 5% of the truth table. This makes the 10%. So we can say that the 90% of SR is JK flip flop. As far as the excitation table is concerned, we will be dealing with that also. Or you can say that we'll first take the characteristic equation. Okay, that is characteristic equation. Okay, in characteristic equation we will be dealing with the characteristic table, and we will be seeing at what place we will be having the values. For example, here if we give the numbers from 0, 1, 2, 3, 4, 5, 6 and 7. So as far as the K map is concerned, okay, so Qn Jk, Qn bar, Qn, J bar, K bar, J bar K, Jk, Jk bar. Here it is 0, 1, 2, 3, 4, 5, 6 and 7. Now we have to see at what numbers we are having the values. Okay, 2, 3, 4, 6. So we will be having 2, 3, 4 and 6. So we will be having this pair and we will be having this pair. So the Qn plus 1, that is the output next state, will be Qn bar J for this pair, and for this pair we will be having Qn K bar. This is the characteristic equation for JK flip flop. Okay. Now as far as the excitation table is concerned, in excitation table we are having the present state, that is Qn, the next state, okay, J and K are the outputs, 0 0, 0 1, 1 0 and 1 1. Okay, so we have to look out for these values. Now see, we have to look for present state 0, okay, present state 0 and next state 0 in characteristic table. Look, we are having two situations, present state 0, next state 0, present state 0, next state 0. Okay, now in these two conditions, what is the value of J and K? The value of J is same, 0, but the value of K changes. Okay, so J remains the same, that is 0, but for K it is changing, then we can apply don't care. Okay, now we look out for present state 0 and next state 1, present state 0, next state 1, present state 0, next state 1. In this condition the value of J is 1, so we will write J 1. The value of K is again changes from 0 to 1, so we will apply a don't care condition. Now we will look out for present state 1 and next state 0, present state this one, present state 1, next state 0 and present state 1, next state 0. In these two conditions the value of K is same, that is 1, So we'll write 1 for k, and for j the value changes from 0 to 1. So we'll write don't care condition. Okay. Now the last value for 1 condition, this one, present state 1, next state 1, present state 1, next state 1. Okay. In these two conditions the value of j changes, so we'll write don't care, but k remains the same, that is 0. Okay. So this completes the excitation table. So in my coming lectures we will be discussing more on flip-flops, that is the remaining flip-flops are D flip-flop and T flip-flop. The speciality of D flip-flop is that whatever we give the input, the same will get the output, and the T flip-flop, that is a toggle flip-flop, if we combine J and K, okay, and there will be one input, okay, then another input will be there, that is known to be T. The circuit remains the same, only T will be here and will be combining J and K terminals. Okay, so this is all about JK flip-flop. In my coming lectures we will be discussing more on D flip-flop and T flip-flop. Thank you.